AI-powered avatars. Victor is going to talk about IoT. Ola and Femi, AI-first strategy. Asanju, building developer tools. And Prakash, image optimization. And I think Mike's going to talk about clean architecture if we have time at the end. So each talk will be about 15 minutes. Please leave the questions to the end. If there is time for each speaker, we'll do questions. If not, we won't. But obviously you can network after it as well, so it's fine. Let me take a look through. So recording is in progress. We are going to stream this to YouTube as well. If you don't want to be on YouTube, then just come and let us know. Here's just a shout out to all of the organizers. Josh and Samson are here today. A quick note about our sponsors. So Alex is usually here with Hyperloop. If you're looking for a new role, if you're recruiting, get in touch with Hyperloop. And we've got a JetBrains giveaway that Samson's probably spoken with you about. And the SNA Academy is kind of helps to upskill new engineers. And obviously we wouldn't be able to do this without Eagle Labs. So just a few slides on some of our sponsors. Get through this so we can start the talks. Josh has also printed out some .NET Liverpool t-shirts, which I think that he's selling to help the meetup. So go speak to Josh if you would like to see what's on offer. And we're going to start with Stephen, but it's obviously a very friendly group, but a lot of people here haven't spoken before, so give a lot of grace and patience, and please don't interrupt, all that sort of stuff. Everyone here is really nice, I don't need to tell you that, but I'm going to start with Stephen. There you go.
Thank you.
Do you want a mic?
No.
Sounds. Not after I've used it.
I actually don't mind if you interrupt, to be honest with you. Thanks, Chris. Thanks, Josh. Hello, everybody. What an honor. Opening out the lightning talks. This is cool. This isn't my first slide. Have you actually put my slides in, yeah?
Yeah.
Cool. You've changed the font.
Someone else. Sorry.
So my name's Steve. I'm a .NET developer, 20 odd years doing C#, and for the last 8-9 years I've been doing F#. And right out the gate, I just want to say I think F# is awesome. And so I really wanted to give a talk about it, and I wasn't sure what, hence the title. Then it occurred to me, I've been using this thing every day for the last sort of 8-9 years in my professional job, intermixed with C#, to be fair, but there must be advantages to that, So what are the advantages to using F# as a .NET programming language? This is what I'm going to talk about today. But first of all, what is F#? For those of you who don't know it, it's a fully .NET compliant language developed by Microsoft, started by Microsoft, I should say, back in the noughties, driven by Microsoft today, developed as an open source language. Functional programming, I think I said that already. Why I chose it, it's super, super convenient to use. Okay, so when I started out, there were other languages I could evaluate. That meant I had to change my tech stack or change my environment or whatever. F# is right there in the editor you probably use already. It's certainly in Visual Studio. I think it's in Rider. You can get an extension for Visual Studio Code for it. So, you can right-click, add a new F# project. You can intermix your C# on your F# projects into your solution, which I think is super cool. And because it's fully .NET compliant, all your NuGet packages just work. Your testing stack is exactly the same. The debugging is just seamless. So really, really convenient to get into. And I think that was one of the reasons why I stuck with it, because I think if I'd have gone with Clojure or something like that, I reckon the stickiness of changing environments would have got in the way. So that was the reason I chose it, the convenience. But the reason I continue to use it, the first advantage, I think, we'll talk about language features. Now, there are lots of things that I could talk about here. I personally really like the language. It's a very terse language. So you tend to write less code to get at what you want to say. Although, to be fair to C# over the last sort of few versions, it's moving that way as well. I really like the fact it doesn't have null as a proper value. That eliminates a whole class of problems. I like the way it deals with asynchronous computation as well. It's not tasks, it's a computation sort of solution for that. I really like the fact that it's immutable. Although initially you sort of think, but actually, again, another whole class of problems that have been sort of taken away. But the standout feature, I think, for me, the thing that I would miss the most is discriminated unions. These are I think, a real superpower inside F#. So what are they? What do you use them for? And so I suppose the easiest way to describe them is they're an OR. They express an OR relationship in a data type. So typically your classes, your records, your structs, sort of express an and, you know, so a user is like a first name and a last name and an email address. A discriminated unit expresses an or, okay? And so I'll show you sort of how you might use them. So this is a typical, let's say this is a typical user record. I had to do this in C# because of something you'll see in a minute. First name, last name, email address, and then your boss comes along and says, what about phone numbers? We want to collect phone numbers, so you just add a phone number. And then somebody says, well, hang on, I don't want email address and phone number. I can have either or both. That's the business logic. That's the business rules. So like as a good C# programmer, you might do this and express the fact that they're nullable, right? So I can have one or the other or both. But what's also in this little declaration here is that it could be neither, right? So your type is betraying your business logic. Now I know you could guard around that, right? You could have private constructors and you could do all that kind of fancy stuff. But F# has this sort of idea of making illegal states unrepresentable, which I really, really like. So the way that I would solve this in F#, this is sort of all you can do in C#, I think. But the way I'd solve it in F# is I'd replace those things with a contact info. And that's my discriminated union, which would look a bit like this. Why is that hopped on? Oh, have all my animations broken, Josh? No, I don't know. I'm just, looks like they have. Damn it. So here's my contact info. And as you can see, it basically expresses my three states that I'm interested in, my three cases that I'm interested in: email only, email and phone, of string, string, and tuple of string. And the really nice thing about this is no way to express nothing, neither, right? So instantly I've got my business domain, one of my business rules burnt into a type. And the compiler will now help me with making sure that, I cannot make one of these that represents neither email address or phone number, which I think is absolutely fantastic. So the compiler is now on my side enforcing my business logic because I've burnt it in at the type level. And then this bottom bit is like the counterpart of the creation bit, which is the deconstruction, which we do with pattern matching in F#, which again, because it's been designed into the language from the off, is really, really nice and succinct. So, you know, info is a value of this type. And then I can just deconstruct each of its cases. And you can see this is effectively a lambda that's just going to do something with that case, having unwrapped it into its constituent parts. Now, these are all strings, but they could easily be ints or bools or another record or whatever it might be. And the thing that's not in this, actually, you might look at this as a C# developer and think, well, I could do this with a class hierarchy. You know, you have an abstract base class, you do blah, blah, blah. And then this is, you know, if you squint, you can get C# sort of switch expression would kind of get you somewhere towards this pattern match. I really like the switch expression in C# actually, but what you can't see in this is that with an inheritance hierarchy, it's non-exhaustive. You can always add another type of contact info, as far as I'm aware. In a discriminated unit, it's exhaustive. These are the only three cases that you can have. And if you add one, where this gets really nice is if you add one later on, your boss says, I need to collect postal address. So you add postal address to the bottom, your whole code base lights up where you haven't managed it, where you've done the unpacking. So again, your compiler's on your side going, wait a minute, you've now got this new case you have to think about, which it can't do with if you think about an inheritance hierarchy, you can't do that. So I think that's really, really cool. So that's like the domain modeling use case, if you like. I used to do a lot of desktop apps, and now I do a few more web apps. And I've noticed this sort of model where you basically send something off to a service and a controller, and then you map it back to a response, you know. And these are really good for this. They're like result types. So, you know, here's my service result. So I'm not just returning an object or null, or maybe throwing an exception, which is quite idiomatic in C#. I've now encoded all the things that my service might respond, this one method call might respond. And then in my controller, I'm really just mapping these directly to HTTP responses. It's just really, really, really neat. I really like that use case, actually. So that's, yeah, discriminated, as I said, before I saw these. Now that I've seen these, I don't know how I map to model the domain ever. Because in any sort of medium, well, any domain of any complexity, you've got an OR relationship. There's always an OR relationship there somewhere. So this is the one thing that if I couldn't do it in F#, I'd have to find a way to do it in C#. And to be fair, there are libraries that you can kind of get this, but I always think, like, you know, people going on about use the result type in C#, or, you know, discriminated unions are going to be coming in 2 versions or whatever. Don't bother, just do it now. Right click, F#, class library, away you go. I would absolutely suggest you do that. So that was language. That was a quick wrap, sort of main thing of language. Architecture, this is a bit sort of, it gets more tenuous from here on in, but this is my experience, right? I feel like I'm gently being pushed into the sort of pit of success when it comes to architecture for using this. And so let me just give you the context. This is roughly how my apps look on a broad scale, a broad sort of component level. And this is like a typical clean architecture kind of look. My UI obviously separate. The reason the UIs tend to be in C# is because the tooling is better. So I used to do WPF apps. Tooling is all in C#. I now do kind of Blazor apps. Tooling's better in C# than it is in F#. So I'm happy with that. And one of the nice side benefits is that this initial link, there's a little bit of friction across that boundary. If you're unwrapping F# native types, particularly things like discriminated unions in the UI, especially if you're trying to do something with them, it's a little bit painful. And I quite like that because it's always reminding me that I shouldn't be doing stuff in the UI to start with, right? So it's forcing me to do things where they should be done, which is down in the sort of the core of the app. So that's one nice little side effect. One of the others is that in F# there's a strict dependency order to your projects. So you cannot use a type before you've declared it. Not like C#, you can just throw a class, the compiler goes, don't worry, I'll find that class for you later on. And it does this sort of look ahead or double compilation or whatever it does. In F# you have to declare the type first. And so you inevitably end up with a project that goes from simple types down to more complex types. And it sort of goes from your core down to your edges, down to your UI. And that sort of manifests itself in the relationship between components. So all the arrows go the same way, which if you've ever seen that, that map of like, I think it was it one of the Linux browsers or something like that? They mapped all the components and then they did it with like Windows Explorer or something like that. And like the Linux one was all beautifully kind of, everything flowed in one direction and the Windows one was all over the place. And this is kind of, it just gently, I think it just sort of gently nudges you in that direction, which again, another nice benefit. And it all just, you can do this without doing anything in F#, but I just think the language is pushing me gently in the right direction, which I think is quite nice. And then there's a final thing, which is sort of F#y. This is obviously dirty. It's got loads of I/O going on, as is the app and the services layer. Inevitably they're doing lots of I/O. If I get things right, and because it's supported by the language, I can end up with this core, which is where all my business logic is, which is lovely and pure and referentially transparent. And because of that, is super, super easy to test because there's no mocking anything like that. It's just really, really straightforward. And that is something that some people have called like functional core imperative shell. There's a sort of description for that. So in effect, you keep all your I/O at the edges and you end up with your business logic and your core domain is as pure as it can be. And again, because of the features of F#, I just feel like it pushes me that way because you're wanting to make these things pure and referentially transparent. So a little benefit to the architecture. And then the final one is, I kind of learnt me a new paradigm along the way, which is not something I expected to do, weirdly. I picked up this language thinking I was learning a language. And I should say that F# is functional. They call it functional first, which means that it sort of promotes the functional programming style, but it doesn't mandate it. So you can do OO, you can do imperative programming. And really for the first 6 months or so, I was definitely doing object-oriented programming in F#. I was just using a different language. But then you start looking at the language, you start looking at the Stack Overflow examples, you start reading up a bit about why this type exists. And the functional paradigm starts to kind of just slowly ooze its way into you, And I wouldn't say I'm an expert, but I do feel like I have internalized something of that paradigm now, which is brilliant because, now it's not just one big OO hammer and everything's an OO nail, right? I've got this other way of looking at things. And of course it's transferable because it doesn't just apply to F#. When I'm looking at C# code, it also applies to C# because it's a paradigm. It's sort of below the code in a sense. So I think that's been really useful. And I would say to anyone, if you're thinking of picking up another language, try and pick one that has a different paradigm attached to it, because why not? You kind of get more than double your benefit for learning the language. And I think, yeah, that's it. Here's some things if you're interested. And obviously, any questions or if you want to chat, God, it'd be great if somebody picked up F# and we could actually talk about it, because literally I know nobody who does F#. So, but yeah, thank you very much. How are we for time? I'm over, just in case anyone wants.
So, I think the major issues that F# has is that it doesn't have a big community. There is not a big community around it, apart from videos from Don Syme and a few other people. You barely get to see any community, you barely get to see any jobs for F Sharp. So it's really difficult to pick it up and follow through. So what's your advice for someone? Because I've dabbled into it a few times,
Okay.
but what discouraged me is that there was really no community. Nobody else around me does it. No, there's no one to talk about it to. So I'd
Yeah.
like to hear it.
Well, I think that's true in terms of a physical community. I mean, there used to be a conference actually down in London, which unfortunately went bang. But there isn't so much of a physical community, but there is a very good online community, and there is an F Sharp foundation which you can join. Which again, it's a notional community, but there are. I've never found that side of it as a problem, and because it's backed by Microsoft as well, I find there are quite a lot of good resources out there if you want to get into it. You're right about the jobs. That is one thing, but I'm quite lucky because I'm self-employed, and so it's like I get to do it. My clients don't necessarily know or care, so I get to do it anyway, you know. But yeah, I've often thought like, I wonder if I could actually get a job doing F Sharp. There are jobs out there, and for what it's worth, I think they're quite well paid. But you're right, there's not as many as there would be in C Sharp. But I wouldn't let the community get in your way. I think we can chat. Just come to .NET Liverpool. We'll chat about it every month. It'd be brilliant. You know. So, thank you though. Anyone else? Are we done? Right. Okay. Thanks a lot.
Yeah.
Cool. We're good to go? Nice. Sweet. Hello, everyone. So my name is Dr. David Tully. I run a small immersive company over in the sunny side of Birkenhead, i.e. the dark side. Does anyone actually live on the Wirral, over on the other side? A couple of people. Sweet. Everyone else from around here. Sound? Yeah, so my background is in academia, teaching games development at Liverpool with John Moores. That'll come apparent in a little bit, slides forward. And this has been around about, yeah, kind of, well, 2 years in the making for Pixel Persona, but also around about 2 years since I've been to .NET. So it's very awesome to be back. Josh, swearing? Try and, yeah, no, don't mind. Okay, sounds. Just for encourage, just for the YouTube channel. Sounds. It might come out. So yeah, cool. Yeah. So again, I'm here to kind of just talk a little bit about what we're doing, what we're building, and why we're building it. I kind of feel a bit like a fraud coding. I haven't really done it for too long because I've been trying to run the company. When you run like company, HR, staff, whatever, you don't really do coding day in. So like, look, listening to F Sharp, fucking cool. I like it. Right. So what we've been doing, well, every year there's roughly about 500,000 redundancies made in the UK. Now with AI pushing it, loads of people are now becoming kind of unemployed. Juniors are kind of going, you need to be intermediate, high-end people. Yeah, the actual strain on, authorities, job centres, we work quite closely with a lot of them from building like lots of VR applications around mental health, immersive tech to try and get people back into work. And I think from us, especially Liverpool, I know there's like maybe people around here, Liverpool kind of has a bad rap. Has a bad rap with high unemployment. So you go to the Wirral, it's pretty much amazing areas and then shitholes. We want everyone to be actually get jobs, and that's kind of where we're taking our company, Scene Graph Studios, is to just build tech for good. That's what we've been doing for like the last 4 years. And the whole academic side of things, like when I was teaching at John Moores, you do maybe 1 or 2 mock interviews with a couple of the good students. Why? You don't have time. You don't have time to do all the teaching. And then us working with a lot of schools, and we can see here, Royal Met College, we asked them to do a piece of work and just say, how much does a mock interview cost? You don't do them because a lot of the students that you're sending our way can't talk, can't do anything. Like it's struggling. And I think if anyone runs businesses, a lot of people coming in now just can't get over that first 5 minutes of just having a conversation. And then yet the piece of work, it showed that as about 240 to 250 pound for 1 mock interview. That's not even a good mock interview. That's like just 15 minutes. Certain university that I used to work at, it's 500 pound. They'd have a staff member taking your whole course stuff. 500 pound for half an hour. Cool. Liverpool Uni, they bring in specialists. So specialists in around, doctors come in. Those doctors will be paid 1,600 quid a day. They bring 5 of them in. It's about 10 grand going to an agency to do mock interviews. Cool. Can't AI kind of help to do this? And this is what we're doing. We're using AI to help people get jobs instead of AI taking jobs. This whole sentence got us onto the NVIDIA Inception program, i.e. good kind of marketing employees. So if you can get onto marketing, yeah, people like it for that. Cool, and this is what we've been building, AI avatars that you can actually have conversations for. The whole interview thing kind of comes in as a scenario, or we're pushing out our Unreal Engine work, i.e. MetaHumans, AI avatars, all through 4G, all from our office in Birkenhead, and just for you, just to practice talking. We're working with a lot of autistic charities just to get people talking. A lot of people in the dev environments don't like talking. Cool, if you don't like talking, you're not going to get a job because those first 5 minutes are kind of screwed. But then we're also doing quite a lot of other scenarios. And as I said, yeah, we're on the NVIDIA Inception program. We're working with AWS to get up onto the cloud. Cool. So before I kind of get into our architecture, a little bit more around it, I kind of wanted to say, we do a lot of research into the back end of AI. AI, ChatGPT, blah, 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 it's all buzzwords, buzzwords, buzzwords. To us, each one of these kind of AI models all have personalities. So we like using Llama 3.2. Why? Is because we kind of think it's the most stable and kind of conversing models, but you've got Llama 3.2 chat, very happy, very smiley. When you're having a conversation to it, it'll do follow-up questions. Cool, yeah, how are you? Yeah, to kind of keep on going, obviously with a bit of prompting. But then Llama 3.2 instruct, when you're starting to bring stuff from a RAG database, we call this the arsehole. Why? Is because it just doesn't talk to you. It tries to retrieve stuff from a database, from a RAG, and just goes, here's your information. The reason why we call it an arsehole is when we're using it as an interviewer, it'll just go, okay, answer this question. Right, next question, next question. Doesn't try and work through from any of that type of stuff. And that's the idea from it all. Each one of these has so much kind of personalities from them. And the reason why we use Llama 3.2 and not 3.3, the latest ones, come on in, dude, is purely for the fact of a lot of the new ones just spam emojis. I don't know why Meta want to put emojis in conversational language, but hey ho, it is what it is. And one thing that we do with a lot of ours, so from prompts, from system prompts, from prompt engineering, what we do, which kind of sets our kind of AI avatars apart, is we give our AI families. A lot of these prompts don't. So I go, oh, you're acting like a business manager. Cool. Business manager with AI doesn't know what you're going through. They don't know, cool, you're on bankruptcy. Do you have depression? Do you have a family? Do you have kids, sick dogs? This is what we do as a company, kind of put all that train on top to actually give them a lifespan. Why? Is so you can actually relate to them a bit more. Relating to ChatGPT, it's okay, but then, yeah, going through it all. Voice options, if you're into this type of stuff, 11 Labs, can't beat it. It's awesome, unless it goes down because it's all on AWS servers. So that's kind of a little bit of an issue there. We like to kind of use this for a couple of hours because we're building like receptionists and their voices are just amazing. Previously, we used Piper. Piper is very good, stupidly fast with text-to-speech models, but to actually train your own voices, i.e. mine, you'd have to have about 3-4 hours worth of audio, but then that 3-4 hours of audio will just be monotone Dave. So your AI will sound monotone Dave. You've got to go through emotions. And this is what we've been building over the last couple of months. So Pixel Persona, we have been kind of looking at the chatterbox stuff, but we're getting emotions into our AI voice. How you do it olden times, like if I say olden times, 2 months ago, i.e. 2 weeks ago, this stuff moving too fast is Piper. You need to do an angry voice. So 2 hours shouting a script. Then you have to do a happy voice. And then the LLM will just put some little tags or emojis saying like smiley face. Then you swap out the AI voice model. Yeah, it's getting there where now we can just do 5 seconds, map your voice very fast. And then emotions are just built into the AI models themselves. Our architecture, we like to get into the nitty gritty stuff. So from system prompts, sorry for some of the formatting, it's all right. Yeah, so we've been using user configs, so the actual system prompt, the user prompt, and our RAG data going through there. We specialize in making lots of speech to text, text to speech, and understanding how this all fits together from it all. And we're building everything in-house. So we just spent around about 40 grand on new servers inside of the office. Why? Is because I'm too stupid to understand AWS and all these cloud infrastructures where we get onto the bare metal. The other reason why we get onto the bare metal is so we can understand what's the difference between a 4080 and an A6000 card. Roughly about 1 millisecond speed difference. When you're doing huge prompts, yeah, go for the A6000 ones. If you're having some basic conversations like asking questions, you can get away with a 30 series GPU. You don't need high-end GPUs. And I wish I would have known that before buying a couple of A6000 cards because, yeah, completely overkill. But that's the idea. We can swap out Langchain, Olama, all through in, and then sort out these temperatures. But specifically, the reason why we're doing this, using Unreal Engine for that kind of front end, is we can have one A6000 card, but technically because our responses, because we do everything bare metal ourselves, we can have basically a second response time from you talking to it, press go, a second later, the response comes back on this card. We're kind of thinking, okay, 59 seconds, the card's doing nothing. So we split this all up, all on Python. I think Fast API that we're using now, which is pretty good, asynchronous, but we can have multiple avatars all sharing the one GPU through one API call, which is pretty decent. Why is it decent? Quite scalable. You need another one, just throw in another GPU, and then just keep adding loads of 3D avatars or web-based avatars. Why even do this? Well, if you're doing high-end 3D, schools are cheap, they don't have good hardware, but then this can just stream, and this is what we're doing with pixel streaming through Unreal Engine, just streaming through HTML, and you can just work it on any device. Why? Is because we want the general public to be using these to actually get talking. You can't have someone say like, oh, right, yeah, you want to do a mock interview? Cool, just buy a $3,000 gaming machine. Doesn't work, and yeah, you have to push it through really crap machines. Cool, industries that we're going for. We're going for like basically anything to do scenarios. I won't talk too much about all these, but I will say from the health and social care, we've been building an avatar. So one of the universities came to us and just said like, we spend a lot of money getting actors in to train our nurses to come in and pretend to have bipolar disorder. So the nurses can have something to just ask questions, fail with them before going into the NHS. Cool, with all the cutbacks, they stopped all the actors coming in. So these nurses are now being trained in universities to then go into the NHS to say, oh, I think you've got bipolar. Cool. Once you're diagnosed with bipolar, or wrong diagnosis, it takes 9 years to get off it because of the tablets, the whatever. So the average time to just actually get a re-diagnosis, 9 years. Bit of a fuck up that. Cool. All from not spending a bit of quid on actors coming in, even though you're spending loads of money going on there. So we've built an avatar that believes that it has bipolar or ADHD, 5 minutes. Cool, perfect. And this is what we want to do. We give them the brain, and we're going to come back and say like, oh, we give them families. A lot of the trigger points with people with bipolar is from the families and how the parents acted with them that just bring up trauma from different cases. Cool, you can't do that if you have just a basic chatbot going from there. We are working with Wirral Council as well to build out child avatars to allow teachers and staff to understand about safeguarding. So if you spot a bruise on a child, how do you even bring that conversation up? Well, you can't unless you're actually having that conversation with a real child. You can't fuck up. Cool, but with AI, you can fuck up as many times as you want. So we've been focusing quite a lot. So these should be videos, but it's all good. It's just us talking to them all. We've been focusing quite a lot over like last year is to just do AI interviews because you've got to keep with one and you've got to go with one. At the end of the interview, we get AI, well, ask you loads of questions, you answer them, but then we're spitting out PDFs to actually give people that feedback from sentiment analysis. Each one of the questions and answers, we kind of just say, okay, here's what you could have said, here's what you should have said. And this is the kind of cool part around this. If you're selling software to schools, they don't give a shit about AI. They give a shit about PDFs. They love a PDF. Everyone loves a PDF. Cool. So our traction, we're in about 26. I know we have 30 schools. A couple more now. Just testing the actual interview skills training. This dude on the top, he worked for the NHS, going to get a promotion for around about 4 years. Why? He came and used our avatars. He didn't talk. He just assumed his kind of bosses knew what he was on about. Oh, yeah, you know I can do the job. Okay, cool. You have to start talking. Even our avatar said in the review saying, you're not talking. You might know it all, but you need to talk. Cool, he did it again. It was a little bit better. But then, yeah, he didn't get a promotion. He went for completely different jobs 2 weeks later. Got it. Better hours, so we know that it works. This dude in the middle, first time he actually used our avatar, shaken, dead nervous, even to an AI avatar. Second time, pretty more confident. Third time, speaking, talking about all the work that he's doing about 3D modeling, but then our AI spotted in his CV that he didn't have any of the experience that he's been talking about. in his CV, even though that he wants to get a 3D modeling job. He's not talking about Blender or any of the work that he did with us. Cool. He went for a job interview, felt confident, didn't get it. But the fact that he went for an interview, even though that he was shit scared previously, he was like, oh, that's fine. They give me feedback. I just don't have enough experience. So we know this idea of people talking is the way forward. We just need to make it actually viable, i.e. cheap, and use AI to actually get people jobs. So yeah, so that's what I kind of wanted to talk about, show high level, and in short, ask for your guys' help. I want to make our avatars more Scouse because frankly, it's so American, sovereign state. That's us in a nutshell. So if you've got any questions and it's time, sound. If you don't, there's more pizza, so we can have a chat in a break. But if you guys got any thoughts, any ideas, or if you just want to get involved, please do so. And if you think that it's shit, tell us that it's shit and we'll make it better. So yeah, nice one. Thanks, guys. Wolf, nice one, dude.
Okay. Hi, everyone. Good evening. I am Victor Mujica. Today, I will show you how the ESP32 have a feature called ESP Now that can allow to connect different device without the use of Wi-Fi, router, or internet. Okay, about me, I am electronic engineer. I have experience in power control and automation. Well, basically because in the industry, it's quite difficult connect device in the automation when you are a lot limitation, like a lot the place is quite difficult to get a Wi-Fi network or connections. So there is why I love this feature ESP Now, because it can allow the simple way connect two device and do by low latency. So what is an ESP32? Basically, it's a small microcontroller that have Wi-Fi and Bluetooth. Also, the CPU is a dual core, the 240 megahertz, that for a microcontroller that costs less than a coffee is pretty good. Okay. So we have several GPIOs that we can use for different applications. We have SPI, I2C, serial communication. We can connect displays, sensors, relays. So what is the problem about the IoT today? So basically, if you want to connect a device, your device, to another device like sensors or controllers, you need basically use a router, and after that to the cloud, and then the data it will reaches to the another device that is slow, is power hungry, and is complex. So the idea of a ESP node is a direct communication. Basically, if we can see here, oh.
Can't step in front of it because it will.
Okay. Sorry. Oh, yeah, sorry. So we can see in that diagram that we have a sender direct to the receiver and another sender to the send receiver. And then this receiver can communicate with the cloud by Wi-Fi connection. So basically the system is going fast. It didn't need a middle device. Yeah, exactly. And you save a lot in energy and in cost. So how ESP now works? Okay, the the classic model of Wi-Fi, we have all these layers. So basically, ESP now eliminate the application layer, the transport layer, the network layer, and just leave it the MAC addresses and the physical layers. So that is basically. So the ESP32 switches on the Wi-Fi station, but don't use the access point. So advantage. What are the advantages about this? Okay, it's ultra fast. Latency less than 10 milliseconds. Low power. No router needed. Multi-device support, so you can connect one-to-one or one-to-many. And also, you have an optional encryption. So the encryption is pretty good. Use cases. We can use this for a smart switch lamp, sensor network to masters, wireless controller, and in industrial or robotic link. So the and the application that you can imagine are basically a lot. So the basically we can see this like a walkie-talkie connection. Okay, let's try it. So it is possible to, yeah. Ah, perfect. Okay. Like we can see on the left we have the sender, and on the right we have the receiver. So the sender is sent every second a messenger, a message to the receiver, and by this they use the MAC address of the receiver to send direct to that specific ESP32. Okay, and that we can see the instant communication. There is a random number that it matches with that exactly in the same time. Let's go to see how the sender is working. Okay, first than all, we initialize the non-volatile storage, volatile storage. That basically is like partition of the ESP32 where we can store information that it will keep even if we hard reset. So after that, we initialize the Wi-Fi station, and then the ESP now protocol. Then we set the MAC addresses and send the messages. So if we can see, oh. Say again, sir? Full size. Do you know how to?
Control plus, I think. Control plus. Yeah, control plus.
Perfect. Okay. Like we can see here, we activate the MVS flash. Okay. After we initialize the Wi-Fi stack, only the station, no access point, because we need the radio, the Wi-Fi for activate the protocol. Then we activate the ESP now initialize and register the callback. Basically, the callback is this code that it will print the MAC address and show that the connection is arrived to the receiver. If I stop the receiver, we can see it's failed. When one time I start again, is the communication again working. So then we set the peer or the MAC address. We also can see here all the configuration at the MAC address, the interface, the channel, if we want to use different Wi-Fi channels, and the encryption. So we can add an encryption for protect all information. Then we send the messages, the message. Like we can see here, sorry. We have a random number and counter and the message. Better. Okay, good idea. So now we are going to send this message every 1 second to this MAC. We can also do a broadcast, send to multiple MAC in the same time, or scan all the MAC available. So now we can see the receiver. Okay, it's again control. Control plus, yeah, there you go. Okay, we can see the MAC address of the sender. Oh yeah, sorry. We can see the MAC address of the sender. Ooh, crash. MAC address of the sender, the length of the information, the power level. So by this power level, we can also use different ESP32 and get location by the information using the different unit in the same time. Well, the messenger, the message, and the random counter. Okay, how this works is similar to the sender. Yeah, only that case we activate the MVS after we initialize the radio station Wi-Fi without access point, and then the ESP now. In that case, the callback is on is before show the message in the monitor. So it's that. Oh, sorry. This one. All that it will be called when the interruption happen in the ESP now. that it will show all the information. And then the last is just leave it in that case, because we have a very simple code, we leave it 1 second for avoid the watchdog reset the system. So now I would like to change to the, yeah. Okay, perfect. Well, conclusion, that is fast communication for IoT devices, a simple peer-to-peer connection. It's perfect for automation, sensors, work anywhere. You don't need a router, you don't need Wi-Fi, it can work offline. Is you think in this, ESP32 is the brain, and ESP now is the walkie-talkie. Is any question or, yeah? Uh, well, the maximum that I haven't to see or reach is 100 meters, but without obstacle. It's the same of Wi-Fi, because it's just the same radio Wi-Fi. If you have a Wi-Fi at home, maybe you go outside, it will not work anymore. But if you put it in the roof, you probably arrive to 100 meters. So it's quite similar. Sorry? Uh-huh. Well, good question. I didn't test exactly, but the maximum, but it can be similar to that you have in the frequency of the Wi-Fi. That in that case is 2.4 gigahertz. So I don't know exactly, but it can be quite good.
The network and that can be noisy.
Uh-huh. Say again, sorry?
The environment can be noisy, and how much data can send?
Yeah, exactly. That depends, but yeah, that is quite interesting. That is something that is necessary to test, maybe. But
Jump in. So we're going to
yeah.
have another break now, but
Okay.
10 minutes. I'd definitely encourage go and chat to everyone if you have any questions. Please left, and we'll start up again in 9 minutes. Awesome. Amazing. Thanks.
Yeah. Thank you.
Oh, sorry, I've got to say, I've got to scan this for other keys to get ready to go to the launch. Last chance.
I have gone in. Means this just so that. Yeah.
All right. It's good to be in Liverpool. It's my first time here, and my first time also attending the .NET Liverpool event. And I love the previous slides. I mean, the previous presentations. So today I want to talk about some of my findings with .NET 9 and specifically about semantic kernel. Yeah, my name is Femi Davis. Femi Davis is short if you have trouble calling that. All right. So one thing I've noticed is um, I've been writing with C#.NET for very few years now, and sometimes there are instances where there is a trend in the technology world, and .NET developers are left behind, and then you know a lot of us we write to Microsoft on the forum, say provide support for this, provide support for this, and sometimes they push they push tools like, and then in the next 2 years they shut it down, and then you say there is Python support, there's JavaScript support, there's Java support, but there's no C# support. So I'm a senior platform engineer, currently working with Inflow, Notice. So I'm going to briefly talk about all of these points. First about the AI first shift in .NET, and I think for those familiar with the Microsoft journey, you would notice that there's a lot of differences the from the time, for example, when the current CEO came in, Satya. Microsoft embraced Linux. PowerShell went to Linux. I think SQL Server, and there was a lot of interesting things. Windows Phone died. I used to use the Windows Phone, and then they adopted Android, and there's been a lot of positive transformations, and of course confidence. Interestingly, Xamarin also died. I used to use Xamarin a lot, but I didn't go to Mari because I didn't believe Mari is going to live long. Um, but for AI, Microsoft has been very, very interesting about the way they've provided this support for .NET developers to leverage what is available, and yeah, why .NET is embracing AI at its core. And um, I'm going to introduce this extension among other packages that powers this communication with AI. Then, of course, the new foundational model for consumption, understanding semantic kernel, why semantic kernel, and why do you need this layer? And of course, I have a tiny demo if time will permit. All right. So moving from AI as an afterthought to AI as a fundamental platform capability is one of the very interesting things I've seen. Actually started mainly from .NET 8 and now into .NET 9, that we have more accessibility features in terms of inbuilt namespaces, which are abstract um, packages, and also full packages that allows you to talk to different large language models. And of course, I can see that the .NET 9 is prioritizing that as well by supporting cloud native and also AI integrations. Then I'm just going to skip to because of time. So they are also trying to bring standardization as well. Right now, if you are trying to interact with a large language model like Copilot, like Gemini, Claude, and every other AI tools, you have this unified interface. Now it looks like a search engine. All these experiences are brought in into these libraries where you can have a standardized way of sending a text prompt or of sending images or of streaming data in and out, and also plugging in with your local RAG, your local data. And interestingly, in these packages, you have a consistency experience, and of course, type safe on the language, and you can even inject some of these activities into your services or libraries that you have in your project. Then the support for OpenAI, Azure AI, and so many other AIs. Then beyond the simple API calls, you can as well build applications that combine LLM intelligence. So let me just keep this slide. So what this slide is trying to talk about is, imagine you have an application, and then you want to power your applications with artificial intelligence, right? As a C# engineer, now there is availability for you to be able to interact with different large language models in a very fast way, and you can register these dependencies in your dependency registrations, and you can bring that into your classes and consume these methods. Very, very interesting. Then of course, we have some set of Nugget packages that powers this. You have the Microsoft extension.ai, then some of them .openai. There's a lot of first support for OpenAI there, but there's a lot more. I'm going to show them in other slides as well. And of course, they are very easy to plug into your .NET project, either as if you have .NET Standard. I think I plugged it into Mayo app as well, but I've played with it with basic console applications or basic ASP core 8 or 9 applications, and they work quite great. And of course, it's very, very simple. The way to it's very, very simple to integrate it. It's even kind of simpler than using REST, as all the large language models have REST ways of interfacing with them. It's very, very straightforward. Then I'm going to talk more about what semantic kernel is. So semantic kernel is an SDK in simple form that allows you and it's built by Microsoft, it allows developers to seamlessly integrate with large language models. And the purpose actually basically is to bridge that gap, right? Makes it inclusive for .NET engineers. Like I said, usually when there's a new stuff, you find, like on the documentation, you find Python, Java, and some of these Go languages. Sometimes you don't find .NET there. So you will have to rely on perhaps REST methods or community open source libraries to integrate. But now Microsoft have done this fantastic SDKs. Then it acts as a core that runs the AI prompts, and then of course it consumes this namespace as well for talking to models. So I'm going to talk more about that also. Then what are the capacities that it has? So basically within itself, it has the ability also to transform your inputs and add some kind of I don't want to say semantic, some kind of reasoning into it, in the way it communicates with the underlying layers that talks to the actual LMMs. So it's not just taking your raw prompt and sending it. There are some background processes that works there. We have an example scenario there that says, get the latest stock price from Microsoft, and then you can have a definition that calls get price to handle that. Then same thing like an email, send an email to Tunde. Then you can have a method as well that does that actions for you. And each of these actions are are connected to your code like connectors. If you have worked with Azure, there's this beautiful thing called connectors that allows you to easily bridge the gap between your applications and different other services. For example, database. So if you want to connect to database, you will need like the driver of the database, placing your connection strings and start interacting with it. With the connector, it bridge that gap. Automatically, you can easily access so many things there, and this is the experience that they built for you. Then integrations. I have 5 minutes left. So I played with Gemini. I don't have access to OpenAI or the rest. I play with Gemini, and so you can integrate with large language models, multiple at a time, and you can juggle between these depending on the use case and the needs for your application. And of course, you can bring in that extension and then can bring it into your dependency so that your singletons and your scopes and transits can access it. And of course, you can as well connect it also to your data as well. For RAG, there's a way you can extend it that you can feed in data from your database or from your business logic to make this work even better. So I have a code sample that I will have lots of demo, but this is exactly my integration with Gemini. That's simple. This a console app there that says I wrote hello and it's able to reply. The normal text experience that everybody have had, and this is the code behind it. Yeah. So right there, do I press it again? So right there, you will see the first semantic kernel there, which is the nugget package you get to bring in. Then of course you have access to the connector. Now inside these connectors for Google, the Microsoft AI extensions is implemented in the background, and as well you can use this directly if you want actually. And this is how simple it is to get to talk to it. You have your builder, which you can create a kernel builder. You can as well use your own hosting builder for your application and bring in your own service collection. But this is how I implemented it with Gemini. Quite straightforward. Put the model, your key, and you can start invoking this prompt. So if you are talking to Google, all of these things, you use the same very method, which brings that consistency and beauty into it. So I'm out of time. So the future. So I think this is going to be very, very interesting for .NET engineers as the different AIs and talk about compilers and the agents. This will be able to build more of this with this SDK, and of course it can increase your productivity as well for in terms of a business application. And watch out for the new features. Some of those features right now are still in preview, like the Gemini connector that I use is still in preview. I'm sure very soon they will have a release version and it will even bring more interesting stuff. So, in summary, .NET is doing an amazing job bringing focus to AI, and this is guy powering it and semantic kernel. So if you want to learn more, there's a barcode there that can take you to the Microsoft documentation where you can see how this is played out. That's all. Thank you. Any question?
Hi everyone, my name is Babatunde. I'll be talking about building developer tools in the open. Basically, I'll be talking about what I've learned my current place of work and while working on different projects. I know most of us we are using NuGet packages. We download different things from there, but what we don't know is that there are some people that it is their pain point that they are using to build that particular tools that we are using. This is about me. I've worked in different sectors. I'm currently a software engineer at T-Track, and there are a couple of projects that I've actually worked on. The problem, so what I've realized is that there are some tools, SDKs, that we download that along the line, there's no support for it. The reason being that over re-engineering some problems can cause complex solutions. Poor developer experience, if you don't have a solid understanding of what you want to even build, there's another problem around that. You want to solve all the issues, which means that you lack focus about what we are actually trying to achieve. And you are building in isolation because you don't gather more information before you actually go into what you're actually building. The solution framework. There are solution framework, like 3 principles that I've gathered. You need to be able to solve real-world pain points of a particular stuff. You need to also prioritize developer experience and embrace simplicity. Simplicity is the key. So I have 2 open source projects that while I was working, I faced some issues with that at my place of work and also while I was doing side projects. One first problem is this pay bridge. I was working on e-commerce solution, but along the line, I need to use 2 separate payment gateways. The first payment gateway happens to be Flutterwave, might not be used to that. And the second payment gateway is Paystack. Now, they have different payload, different response, but I need to use both of them on a particular project, which now means that I need to understand this particular response, understand this particular request. So at that point, I've been doing it, but I noticed that there can be other people that will face that kind of challenges as well. So that's why I created an SDK that is going to be a wrapper around those 2 payment gateway. The second one is Concraft. So I was working on a scheduling application, and what I realized is that we normally use cron expression a lot. At that point, if you want to give your application to maybe directors, they don't understand what, let me quickly go there, what this is all about. But at that point, I need to be able to show what this actually means. We will understand, but they don't understand. So at that point, I saw a lot of libraries online that I can use, but because of the UI design that we created, that particular library doesn't give me that flexibility. They didn't support time zones. So I had to do a lot of research before I can be able to achieve my own definition of the actual design that the UI designer has given to me. So at that point, I also see that there might be other people that will also face that kind of challenges. So that's why I also created another library that will also solve that particular problem for another user that can have that same problem. So this supports time zone, supports different languages. It's just some little configuration that you will do and you'll be able to use this particular stuff. So for the pay bridge, is going to use, I can't present, I can't demo, but this particular payload is going to be used by all the payment gateway, and this is the sample response that they will all get for all. There are mappings that has been done on it. So for the Chromecraft, it's just a little configuration that you need to do. And based on that, it's going to give you this kind of response that you will get. So in all of these, it's just for you to basically understand simplicity. You have to do just a single thing, do it well. And if you're able to do it well, it's basically for you to achieve perfection. So the action plan. So based on what I've gathered, you need to identify your daily pain point. Most of us will also have like a pain point in our workplace, or maybe a project that you have been working on. You basically have a pain point which another person can actually also face in the nearest future that you don't know. So you need to check if the solution exists and why they are stuck. Build this tool you wish existed. Share early, gather feedback, and iterate based on the usage. Because there are a couple of tools that you will see, there will be a lot of issues, but without people that is contributing to that particular SDKs. So this is the GitHub of the two solution. And if there is any question, I can take it now. Any question?
So, is any company in Nigeria making use of this library that you created?
Not yet, because there is still a part of it that speaks with webhook, which is still pending. Yes.
But at least you are able to use it efficiently.
Yes.
Is it open source?
Yes, it is.
It's just like a sort of like the iteration and feedback part about like the prawn library. Yeah. So the entire idea of like the prawn syntax is standardization. And when you say the prawn tab does the interpretation from human readable to the current expression to what does your library do? Does it basically spit out a human readable version of the current expression?
Yes.
Or does it do the other way around?
No, it speaks out the human readable of that particular expression.
Not the other way around.
Not the other way around.
Okay.
Yeah.
Okay, so like an interface where you put the code expression, it interprets it.
It's going to, yes, it's going to interpret it. You can actually incorporate it into your scheduling, reporting, and the likes. That this with, you need to configure cron expression and the likes. It's not part of this, but the other one I'm working on is Tableau SDK. So what I also noticed is that there is no C# integration SDK for Tableau, and we do a lot of reporting on Tableau, which we don't have. The only SDK that Tableau owns is the migration, but they don't have, if you want to get workbook, configure your permissions and look, they don't have that. But I'm currently working on that. Thank you.
Oh, we seem to have misplaced them. Oh, there it is. Found it. Yeah. Lucky.
Yeah, thank you.
Okay, just got cut off a little bit. Probably my name's too long, but hey, I'm Prakash, and today I'm going to be walking through how image optimization is done using CloudFront. Okay, so about me, I'm a lead engineer working for a OEM who helps, like we help OEMs with their pricing, and that's what we do. Okay, so before image optimization, yeah, we might all come across. It's a way to optimize the images before we deliver them to the users. And how we do that is like compress, resize. Resize is obviously we're trying to optimize in terms of the space we have on the screens. You know, various that could be mobiles, desktops. And then also format conversion is another thing. Depending on the device, we do it automatically. And content delivery network. So what it does is, let's say you have an origin server, you have one server and it's running in one location, but you have users across the globe. And if you want to deliver the network to users across the globe, you would use a CDN, right? So you could use one server and basically reduce the load on your server as well. And compute at edge is now fine. We have a server which is running at one place and we have an audience across the globe. But now I want to be able to enable compute at the user's location so that it doesn't have to come back to my server. And then, yeah, so to reduce that, we use compute at edge, and we'll go through how it works for image optimization. There are a lot of other use cases as well. Okay, so why build an image optimization service again? And part of the reason why this is a question is like there are existing solutions, and this project was for a media company which is serving billions of images, and they could go with one of the existing solutions out there. It could be Fastly image optimization service. Why did we go for something? And it has got to do with a lot of overhead these services come with. Let's say, for instance, Fastly's image optimization service requires you to know VCL, which is a language which nobody has heard of, even I didn't hear. So, so things like that we have to deal with, and the stack of the company, it sort of didn't align. So when maintenance was an issue, and you couldn't customize how we go about, like we had very little control basically, and that is the reason why. Okay, the other one is cost. Obviously, it was like an 80% reduction in costs, and that translates to a few $100,000 for the company. So it's huge. So how did we go about it? So to give a little bit of context, let's say if I'm using my mobile and browsing a website, and I'm using a laptop or a TV or any device, the images would be different. The same image would be laid out differently, and that could be different aspect ratio, different format, and all of that. So any user, let's say we have a tag embedded in the website that it's an image request hits the hits CloudFront, which is okay. What we see there is a CloudFront function. A CloudFront function is a lightweight JavaScript function, um, which is the first thing you encounter as soon as the user makes a request. And why we need a CloudFront request is to normalize. You could do a bunch of things, but the idea is to normalize. And why we need to normalize is, let's say this request you have there, the order could change, or width of 300 could be default. There could be a bunch of combinations going on. And you can imagine if we have a lot of other parameters, what happens is the load on your server increases because, yeah, as a string, yes, it is a different request. But when you normalize it, you realize that it's the same request. So we do that, and we ensure that, okay, is it cached at the user's edge location? Now, what is edge location? Is it a server which is closer to the user, and yeah, so a server which is closer to the user, and if it is available in the edge location, we serve it to the user. That's the scenario we aim for, but it's not a case that we always have it at the edge location. So what happens then is it goes to something called a shield location. Shield location is, there are fewer than edge locations, but it's another step before we actually go to the origin server, like the server which we run, right? And if that happens, yeah, I mean, if you don't, if you have it in the shield server, then again, it's cached in the edge location, and then the image is served, or it could be any other asset, and it's all good. But if you don't have it in the shield location as well, that is when we hit the origin. Like, I mean, there's no other way. We have to hit the origin, and before hitting the origin, we have something called lambda at edge, and this supports two runtimes. It's again not your AWS Lambda, which supports all the runtimes. This supports JavaScript and Python. So those are the only two runtimes as of now, and has a bunch of other restrictions which come along with it. Like it runs for only 60 seconds. Okay, 30 by default, but if you request, you can go up to 60 seconds. And so that is when, I mean, that is when you could do a bunch of things. Let's say you could modify your origin. So let's say now you have 2 or 3 origin servers. You could actually modify your origin in this Lambda at edge based on the request, and then eventually hit the origin. So that is a plan. And so I'll explain the AWS Lambda and S3 a little bit. And this is for any scenario where you want to implement caching and you have to use computed edge. Once it's the origin, you can again have something called, so what you saw there was the CloudFront function is a viewer request, and then eventually we check our cache. If it's not there, then we go to Lambda at edge. That is called origin request. So before we hit the origin, and then now once the origin is hit, and the origin response, you could have another Lambda where you could do a few other things before you actually deliver the content to the user. So, and then we have another thing called viewer response, where again you could do lightweight stuff, modify headers maybe, things like that, and move on. So this is a typical request, and this is a cache behavior. Now, let's say for instance, I cache images and I also want to purge them because maybe I made a change to an image, the master image, and want to purge the image. So that could be another cache behavior. And the reason why I'm stressing on this is we have scenarios where we have APIs which we want to cache. So we don't have to always hit our servers there. You could actually use this and reduce the load on origin. And when there is a change, maybe hit purge, and yeah, that way could deliver content. Now what happens if the image flow is, it comes in, we try to normalize, and then check if there is an image. No, it's not there. And then go to the Lambda, and what that Lambda does is now invokes a regular Lambda. A regular Lambda is where you could have a lot of runtimes are supported. So there we could have all the optimization logic, try and check if an optimized image already exists in S3. If it's there, cool, deliver the image. If it's not, then use the Lambda, optimize the image, and then write it to S3, and then come back. So now once we write it to S3, so that is going to be the origin for this flow. Yes, the image is delivered. Just trying to see if I'm missing something. Change origins dynamic. And one thing, what we're trying to do here is the normalized part, right? It is that to increase the cache hit ratio. Cache hit ratio is something where yeah, we all want our cache to do a lot of the work, and so that is what we're trying to do. So for the number of requests coming in, trying to increase the cache hit ratio means that less work for our server. Yeah, so again, I spoke about that. Normalization is crucial, and so CloudFront functions are like, it's a very stripped down version of JavaScript itself. Like so we could do it for some lightweight task before we hit the check if the resource is cached, and then Lambda at edge, again, a little better, but can't do a lot of the heavy lifting, but can do some. And yeah, so that is what I'm talking about, separation of concerns there. Yeah, and then I mean, a bunch of use cases. Let's say, for instance, when we're okay, this could do authentication. It could Lambda at edge. You could do like use AWS Secret Manager, fetch, and then make requests to the origin using the secrets. A bunch of possibilities there. Changing URLs. Yeah. I mean, API requests. I already dwelled on that. Okay. So if somebody wants to try this out, um, AWS offers a free tier for most of what we spoke about, except the Lambda at edge. There is no free tier for that. Might have to start paying on the go. But and then again, based on your audience, there are pricing classes. Let's say, for instance, you have users only in the West, and you don't have users in Asia or any other parts. So there are classes, pricing classes, which you could use, to target. So to deliver better experience only for those users while saving on money. Yeah. Questions? Yeah.
Not a question about normalization, but just to understand it. Are you effectively turning that URL into I mean, you want to do a string compare, right? So
yeah.
you're expanding out that URL and ordering all the query parameters so that.
Yes. It's ordering. It's also, we could have, let's say there are other parameters, we could have default values,
So
try to fill them in. Yes.
Yes, yeah.
Yeah, key, exactly, yeah. So we're building the key and,
String compare. If this
yes.
cache, so that, yeah.
Right. Any other questions? Okay. Thank you. Oops. What was that?
Oh, nice one. There you go. Right. Amazing job, everyone. That was really interesting. That's actually the best lightning talk turnout we've had, and definitely the best talks as well. Absolutely amazing. So